All right, now we have a brand new situation. For each problem, find the volume of the solid that results when the region enclosed by the curves is revolved. When you see the word revolved, about an axis, it could either be y or x, but in case this says x-axis, so let me give you an example. So let's say you had the square root of x. If it's revolved, it means that you're going to reflect it, and then this is what we're talking about. All right. If it's around the y-axis, you would do that. So let me show you this situation. So look at what we have. We have y is equal to negative x squared, plus 1. That's what this is. This is the height of 1. And how I knew that this would be negative 1 and this would be positive 1, I just set those equal to each other. Negative x squared plus 1 is equal to 0. I added the x squared on both sides. 1 is equal to x squared. Oh, I see what's happening. I forget. And then just take the square root of both sides. So positive negative 1 is equal to x. So that's where I got these. Okay, now, and then notice I drew the reflected. It got revolved. So this thing right here revolved around the x-axis. So we just did a reflection. You could do that in Desmos. You could type in this right here, and then think about what the reverse of that would be. That would be x squared subtract 1. And then this is what it would draw. All right. And then look at what happens. You see these shapes right here? Imagine that these are discs, and we just kept lining, took the area of these, kind of like the repeated infinite number of rectangles, but now we're going to do disc. And the reason why discs are important, well, you can find the area of a disc, right? A disc is a circle, and the area of a circle is pi r squared, right? But remember, the area of these discs are formed by this upper, because you have to start with the original functions. It got revolved, but the upper and the lower are the original. So this function, subtract this function, is what ends up getting revolved. So let's go back and I'll show you what that looks like, and I'll draw this over here. So volume will equal, and this is going to be the lower, upper, and it's pi r squared, and then the dx. But we get this radius when we reflect this, when it revolves around, and then we draw those little discs in there. That radius comes about from this function, subtract this function. So that's what that radius is. And we did find out what the upper lower bound was, negative 1 and 1. And this is pi times, well, the radius happens by taking the upper and subtracting the lower. So negative x squared plus 1 subtract 0 squared dx, because there's an x in here. If that would have been a y in there, you'd put dy. Or if that would have been a t, you'd put dt. So whatever the variable inside the function, it's d, whatever that variable is. All right, so let's simplify one more time. I'm going to go ahead and bring the pi out now, because it's a constant. I can bring that out. And now I have negative x squared plus 1 squared. And now we are going to expand a binomial. So negative x squared squared is 1x to the fourth plus 2 times negative x squared times 1 plus 1. I'm just doing the Pascal's triangle. Plus 1 times 1 squared. So x to the fourth minus 2x squared plus 1 dx. And now you're ready to integrate. So this x to the fourth, when we integrate, becomes x to the fifth, because when we add 1 to the 4, we get 5. So we're going to divide 5. We add 1 to the 2, we get 3. So that becomes 2/3 x cubed plus 1x. And all of that is from -1 to +1. So you're going to do f of 1 subtract. Oh, and look what I almost forgot. It's very important. You're going to lose a couple points if you don't remember that. Okay. All right. You need to remember the constant that we pulled out gets put right there. All right. So let's go ahead and do that. So it's 1 to the fifth over 5 minus 2/3 1 cubed plus 1 times 1. And then all of that, but with the -1 in there. I didn't leave enough room. I apologize for this. There we go. All right, so now what do we have? We have 1/5 subtract 2/3 plus 1 subtract -1/5 plus 2/3 subtract 1. Well, 1/5 subtract -1/5 is adding a positive, so that's 2/5, and all of this is times pi. And -2/3 subtract -2/3 is -4/3, and then 1 subtract -1 is add 2. So go ahead and do all of that. Let's see. So 2 fraction 5, I put that in parentheses, subtract parentheses 4 fraction 3 plus 2 so I got 16 over 15. So this answer right here is 16 pi 15ths. And then when you multiply that by pi, let's see, in the calculator I'd multiply that by pi. It's about 3.35103, and you could put the estimated amount as well too. But this is called the disk method. And then there's going to be a washer method when it's not solid. So there'll be a washer method as well. All right, that's it for this one.